So this is part 2 in adding our rational expressions. You'll notice in this case, this looks a lot like what we had yesterday, and it is. It's for a review. So we take again and say we have common denominators that are monomial terms. I need to find an LCD. So I say, well, I need the 2 x's from the first term and the y, and I need an x, and the 2 y's from the second term. If I look at that, I need these 2 x's, these 2 y's for sure, and then I'm missing that x and missing that y. So I have an x squared that I need and a y squared, and that's my LCD. Rewriting it twice, x squared, y squared, x squared, y squared. Multiply the numerator and denominator by what you need to get from the original denominator to the new denominator. That's a y in this first case. Distributing through 2xy minus y squared plus, need an x in this case. Multiply through, I get an x squared and an xy. Add like terms, there's an x squared plus 3xy minus y squared over x squared, y squared. There are no common factors, even though I have an xy here and an xy here. Not going to work because I have all these additions. These aren't factors. And this numerator term does not factor. There's nothing that multiplies to -1 and adds to +3. So I'm done. Now, you'll notice in this term, we have 2 binomials as denominators. And the question is, do they really have anything in common? They look a lot alike, but do they have anything in common? Let's just look at x minus 1 and x plus 1. X can be any number you want. So if I pick a number like 8, then I'd have 8 minus 1 and 8 plus 1, which would give me 7 and 9 as my 2 denominators. There's really nothing in common between the x plus 1 and the x minus 1. So therefore, our LCD would be the product of the 2. So I will rewrite that as my new LCD. And I always do it twice, once for each term that I have. And then I, once again, go back and ask myself, how did I get from the original denominator to the new denominator by multiplying? This multiplied by an x plus 1, and the second term multiplied by an x minus 1. And so what I'll have to do is distribute through, leaving me with a 2x plus 2 and a 2x minus 2. Combine like terms gives me a 4x over x minus 1 times x plus 1. There are no common factors, so no reducing is left. I don't have to multiply that denominator out, so just leave it as is. In this next term, you'll notice I have an x plus 1, 3x term on the right, and we want to know if there are any common factors here. Now, what I like to do is think about common denominators in a couple of different ways. We have constants, which are just the numbers, variables, and what I call polynomials. The constant in this case is a 3. I have an isolated variable of an x. And then my polynomial, which in this case is a binomial, is x plus 1. Each of these I have to take and look at and say, do I have any common constants in either of the 2 denominators? And the answer is no, because I only have one. Any common variables? isolated variables? The answer is no, because I only have one. And any common polynomial factors in each? And the answer is no, because I only have one. So my LCD in this case would be the multiplication of all of them. So I need a 3, an x, and then the x plus 1 polynomial. So I'll rewrite that. And find out what I need to multiply by x plus 1 to get 3x times x plus 1, and that's a 3x. And then likewise on the right side, I need a multiplication of x plus 1, giving me 9x on the left, 2x plus 2 on the right. Add like terms, I end up with 11x plus 2 over 3x times x plus 1. Again, no GCF on top, no factoring, no common factors on bottom. There's my final solution. So again, let's break this set of denominators up, LCD, into isolated numbers. So I have a 4 in the first term, a 3 in the second term. Isolated variables, that's an x in the first term, there aren't any in the second term, and then polynomials. So you'll notice between 3 and 4 I have an LCD of 12. I need this isolated x, and I need this binomial term of an x minus 1. So that's going to be my LCD. Write it twice. Multiply by what's missing. I need to get from 4 to 12, so that's a 3. I've got the x, but I'm missing the x minus 1. And then in the next term, I'm missing a 4 and an x. So in this term, I have 3 times x minus 1, x plus 1. Next term, I have 4x squared. I'm going to need to FOIL this out. So this goes to 3, and that goes to x squared minus 1 after I'm done FOILing, minus 4x squared over 12x times x minus 1. Still need to multiply a little bit, so that's 3x squared minus 3 minus 4x squared over 12x times x minus 1. Add like terms, that's a negative x squared minus 3 over 12x times x minus 1. I'm never a fan of leaving a negative x squared, so I'll factor out a negative 1 and get x squared plus 3 over 12x times x minus 1. Nothing left in common, nothing left to factor, no common factors that are exactly alike, so that's my final solution. So in this case, there's a much different look. Everywhere in the denominator you have these binomial terms, so I would classify those as those polynomials that I was talking about in the earlier problems. If I want to find an LCD, for the left side, I need an a plus 7 and an a plus 2. For the right side, I have the a plus 7 and the a minus 3. The a plus 7 is in common, but I still need that a plus 2 and that a plus 3 to make sure I have a denominator that all my terms go into. So my LCD in this case is going to be the a plus 7, the a plus 2, and the a minus 3. And once again, I'll re-represent that 2 times for each, once for each term. So a plus 7, a plus 2, a minus 3, a plus 7, a plus 2, and a minus 3. And then I'll ask, what do I need to do in terms of multiplication to get from the first denominator to the second? This needs a multiplication of a minus 3. So whatever I do to the bottom, I must do to the top. And then likewise here, this needs an a plus 2. So in each of these cases, I'm going to need to multiply a binomial by a binomial. In other words, I'm going to have to FOIL. So when I FOIL this out, I get a squared minus 9 because middle term goes, and this goes to a squared minus 4. Add like terms, a squareds are in common, so that's 2a squared minus 13 over my LCD of a plus 7, a plus 2, and a minus 3. And you'll notice this numerator term doesn't factor, therefore there's no common factors to reduce, and I'm done. So now, this case is a little bit different because you'll notice each binomial term in the denominator has a GCF. So what I'll need to do is I'll need to factor those out. And in this case, I have a 4 and x plus 3. And in this case, I have a 5 and an x plus 3. So again, trying to find my LCD, you'll notice I have these constants of 4 and 5. And then I have no isolated variables, but I have these polynomials. So I need the x plus 3's definitely, and then I need a 4 and I need a 5. So my LCD in this case is the 20 from the 4 and the 5 and this x plus 3 term. So I'll re-represent that. Twice for the two terms. To get from the 4 to the 20, I multiply by 5. I had the x plus 3, so that's all I really need to do. This gives me a 5x. To get from the 5 to the 20, I multiply by 4. And I already had the x plus 3, so this gives me an 8x. Add like terms, which is 13x over 20 times x plus 3. There are no common factors left, no reducing. End of story. Now you notice I have two trinomials in my denominator. Make sure they've been factored. Always factor the denominator first. So I get x plus 3, x plus 2, x plus 2, x plus 1. Go over here to find my LCD. Once again, on the left I have the x plus 3, and the x plus 2, and on the right I have the x plus 2 and the x plus 1. The x plus 2's are in common, so I'm going to need that, as well as the x plus 3 from this guy, and the x plus 1 from this guy. So there's my LCD. Rewrite it into both terms. And now once again ask, how did I get from this first denominator to the second denominator by multiplying? You'll see we're missing the x plus 1 in this first case, and in the second case we're missing the x plus 3. These will need to be multiplied by the numerator term, so this gets me x squared plus x. Second term gets me 2x plus 6. Add like terms, x squared plus 3x plus 6 over x plus 2 times x plus 3 times x plus 1. You'll notice this doesn't factor, So that will be my solution because there will be no common factors left. Let's go ahead and go through the same process here. Factor the denominator. In both cases, you'll notice I have the x minus 3, the x plus 2, and the x plus 3 and x minus 3. Clearly, we have an x minus 3 in common. I'll need that. Need this x plus 2. And I'll need this x plus 3. So let's go ahead and rewrite it. It's a little laborious, but I find if you've got it right in front of you, and you're not trying to do too much in your head, stand a better chance at actually getting the problem correct. Figure out what multiplied to get from this initial denominator to this lower denominator, and it looks like I'm missing an x plus 3. Distribute through, get 2x plus 6. In this next term, I'm missing the x plus 2. So I have a 3x plus 6, giving me 5x plus 12 over x minus 3 times x plus 2 times x plus 3. No common factors, therefore everything's reduced. Let's hit one more of these, and we'll try to factor once again. I have an x plus 6 and an x plus 5, x plus 5x plus 4. You'll see I need the x plus 6. I've got the x plus 5s, and I need the x plus 4. So I'll rewrite that. Going to multiply by what changed. That's an x plus 4 in the first case. And in the second case, the x plus 6. Giving me x squared plus 4x and 5x plus 30. But we've got a subtraction, so once again I'll rewrite x squared plus 4x minus the quantity of 5x plus 30 over the LCD. This gives me x squared plus 4x minus 5x minus 30 over x plus 6 times x plus 5 times x plus 4, which is x squared minus x minus 30 over x plus 6 times x plus 5 times x plus 4. However, in this case, we notice in this final trinomial term, this actually factors into x minus 6, x plus 5. And if I look at what I have left, I notice that I have a common factor, which is going to reduce out. So I'm left with x minus 6 over x plus 6 times x plus 4. And that would be my solution. So write your lesson summary, get these problems done. We'll chat more tomorrow. This stuff's getting a lot more difficult, I agree, but just take it step by step and you should be okay.